Math 8, Unit 8, Lesson 1, Part 2. Introduction to Bivariate Statistics, Associations and Trends continued. Okay, first we're going to take a look at this situation. We're going to look at sports balls. We're going to look at two things for each of them. Their circumference, which is what you would get if you took a tape measure and wrapped it around the ball at its widest part, and the weight measured in ounces. So you put it on a scale that measures in ounces and you get its weight. Now, each of these has a weight and a circumference that has been looked up or measured. And you should be familiar, I think the largest one here would be the basketball. So just getting that plotted. Well, the ounces, it's the largest ball. Is it the heaviest ball? Looking around, it does appear to be the heaviest ball. So we need to create our scale in such a way that it makes it all the way to 21 ounces and all the way to 30 inches. 1, 2, 3, 4, 5. Okay, it looks like to get up to 30, we would want to count by 3s up the side on the y-axis. And that gets us all the way to 30. In order to get to 21, I suppose we could count by 3s. If we count by 2s, we'll get to 20. That's good enough for me. It'll just be a little bit off the side of the graph. Okay, so I've got my graph numbered. Now I can start plotting points. The basketball is 21 ounces 30, so that's just a little off the graph here. And let's just go straight across the top there. The baseball is 5 ounces 9 inches. So that's not what I meant to do. 5 ounces 9 inches. I'd put it right there. The golf ball is 1.6 ounces 5.3 inches. 1.6, 5.3 is going to be about there. The soccer ball is 16 ounces 28 inches. About there. The tennis ball is 2 ounces 8 inches. So 2 ounces 8 inches is about there. The racquetball, 1.4 ounces 7 inches around. 1.4, sorry, and 7, about right there. The water polo ball is 15 ounces 27 inches. 15 ounces 27, we'll put it right there. The softball, 7 ounces 12 inches. And the volleyball, 10 ounces 26 inches. Okay, let's count up the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sports balls. Each dot represents one of these sports balls. Now there's some interesting things going on here. Let's first look at the association. It does show a positive association as the weight of the ball goes up. The circumference, the size of the ball, also tends to increase. And that makes sense. If it's larger, it's probably going to weigh more. Outliers. There does look like there's a bit of an outlier. Actually, this set of points down here tends to be on a different line than that set of points. And that actually would be some clustering. So maybe rather than talk about outliers here so much, let's talk about clustering. By the way, this one right here almost looks kind of like an outlier if thought of as the line going up through here. It kind of acts like an outlier. But let's think about clustering. There's some clustering here and here with a gap in between. So let's think of what would cause this. Now, when things cluster and when gaps exist, they're are going to be some real world explanations for it. I invite you to think about what that is. I mean, I'm going to give you my opinion here in a couple of seconds. I think what causes these clusters, if you look at this lower cluster here, these are, well, they're not played using the hand. These over here are played using some sort of bat or racket or club, some sort of handheld tool. All of these sports balls down here. The baseball uses a bat, the golf uses a club, the tennis ball uses a racket, the racquetball uses a racket, the softball you use a bat. With softball and baseball, you also have the mitt that gets used by those in the outfield, also the infield, those on the opposing team. So all of these sports balls in the cluster at the bottom, they are played using some sort of handheld tool. These up here are played with either the hand or the foot, no tool, no additional tool. So they tend to be larger sports balls. In basketball, you know, there's a lot of rules about dribbling and passing and that sort of thing, but no specific tools used for controlling the ball. Soccer, it's played with your feet. Water polo, that would be played in water, and there's no special equipment that you need to interact with the ball. And volleyball as well, no special equipment needed to interact with the ball. You interact with it just with your hands. So these clusters are created by the way the sport is played. Now the gap in the middle is probably because there's no in-betweens here. Now we might look up enough sports and find some points in there. There probably are some points in there. But let's talk a little bit about potential outliers. Think of other sports that might create some outliers. For example, what kind of a sport would create a point out here? Well, the first thing that comes to my mind is some sort of sport that uses a large ball that is very light. Only thing I can think of is maybe a beach ball. If you were playing beach volleyball with a beach ball, it'd take a long time for it to come to the ground, but that would be over here. Also maybe an exercise ball. They are kind of heavy, but they're very large, so they'd probably be up over in this direction. Okay, outliers also could be off in this direction. Let's talk about the type of outliers you might see there. Well, one thing I can think of, a bowling ball is about the same size as a basketball, except it's between 7 and 16 pounds. Well, 16 pounds at 16 ounces a pound would put it way over here at 256 ounces for the 16-ounce or 16-pound bowling ball. About the same size as a basketball, give or take a little, but it weighs over 200 ounces. So that would definitely be an outlier, because 200, that's off of this graph 10 times in that direction. Actually, 25 times in that direction. So that is definitely an outlier. Another type of sports ball that would definitely be an outlier, it's smaller than a basketball, and I'm not exactly sure its circumference. It's probably around here, but that would be a shot put. Now there's a couple different sizes, the male and the female version, but it's a ball that's generally made out of solid steel, and the purpose is to throw it as far as possible. It's a track and field type ball. So there's a lot of interesting things that you could notice by studying the weight and circumference of different sports balls. Okay. Match the data sets with the most appropriate scatter plot. Explain your reasoning. A, month of birth and birth weight for infants at a daycare. Okay, so as you go through the year, do infants tend to get heavier? Do they tend to get lighter? Or does it not matter what time of year they're born? They're all different sizes. I think that third explanation is the best. This would be the month of birth, and this would be the birth weight. I would go with number 2 here. Quiz score and test score for each student in the class. Now we got 2 options left here. Do they increase the quiz score, leading to an increase in test score, or does an increase in quiz score lead to a decrease in test score? Well, on that one, from my experience, students that tend to get higher quiz scores tend to get higher test scores. And then the last one there, the age and value of laptop computers. As a laptop computer gets older, its value will decrease for several reasons. You know, there's newer and better laptops coming out. You need greater processing speed on the internet because, well, the internet has a lot more data on it than it used to. It used to be a lot, there was a lot less that you needed to be able to interact with the world. Now you need a lot more processing power. And at some point, a computer can become old enough that it's not really useful for anything except leveling a table. Okay, describe the relationship between the data, identify any outliers, gaps, or clusters. You're going to be doing this type of thing on your practice. The television size and price. On this, it is definitely a positive relationship or a positive correlation. Now, I'm not going to write out the sentence that we would describe it with. I'll just say it out loud. As television size, well, TVs that are larger tend to cost more. Actually, I'm going to go ahead and write that. Larger TVs cost more. Okay, larger shows an increase, costing more shows an increase. So this is positive correlation. Okay, as far as outliers, this one right here appears to be an outlier. A 70-inch TV that's only about $2,250. I think some of these prices have come down since this graph was made. But this is likely a cheap brand. You may not, that TV might not last very long, but again, it might. Don't know unless you actually try it. As far as gaps go, there seems to be a gap here in the $1,000 range. Not really any TVs there, you know, specifically right here. But I think that gap is caused by this clustering. There is a cluster of small, inexpensive TVs. Small and inexpensive. And then you get into the high-end TVs. Now, this data is probably from when big screen TVs were not as common as they are now. The prices have come down because they are more common and they are able to make them with less expense. Okay, let's look at the next one. Age and number of pets owned. Okay, as we look at this, the person's age and the number of pets they own, I don't see a relationship here, and you probably shouldn't either. On this one, there does not seem to be a relationship between age and number of pets owned. As far as gaps, clusters, outliers, there's not really much in the way of outliers. I mean, we've got 3 with 1, 3 with 2, 1 with 3, 3 with 4, and 1 with 6. Maybe this is an outlier. I'd have to do some statistical analysis on it because I'm just looking at one variable there. Not really bivariate, I was only looking at the number of animals. If I look at the age, I mean the ages go 10, 15, 20, couple of 30, well that might be a 31 there. 35, 40, we've got a couple, well there's really no clustering on age either. It's kind of all over the place. Gaps, not really any gaps either, unless you consider the fact that no one has 5 pets. Now, one thing that might be an outlier, if you have a farmer and he counts his livestock as a pet, then they would have potentially hundreds. However, livestock generally is not the same as a pet. You don't tend to let it in the house. Not that all pets get let in the house, there are outdoor pets. Okay, let's look at family size and laundry loads. So along the x-axis is your family size, and on the y-axis is loads of laundry. I'm assuming this is per week. As I look at it, I do see a positive correlation. And that positive correlation just shows me that larger families they have more loads of laundry. Okay, as far as clustering goes, well, I do see a gap here. It looks like as you go from a family size of 2 to a family size of 3, the loads jump up from about 5 to about 9. It just jumps. Now, we could speculate on what reasons that might entail. One thing that comes to mind, a family size 2 could just be a couple. A couple of adults, they don't make a whole lot of messes, they clean up after themselves a lot of the time. If we jump over to 3, that usually will entail a baby. Babies make a horrible amount of messes. You go through a lot of laundry when you have little kids. They throw up on the bed, you have to wash the blanket. They blow out of their diaper, you have to get that washed. So there's a lot of extra laundry with that third person. And after that, one thing that I've noticed here, it looks almost like it just goes up to here, jumps, and then keeps going at the same slope. And that's kind of an interesting thing that happens there. I would explain the gap based on kids require more laundry than adults would. Even though adults' laundry, they have larger clothing because they have larger bodies. But it appears there is a bit of a jump here from a family size 2 to a family size 3. Interesting thing to note, and it does make sense. Okay, let's look at Atlantic hurricanes. These are hurricanes that start in the Atlantic Ocean. We've got the year and the number. Now, I don't see a positive or negative correlation. A lot of times, people talking about global warming or climate change, as they call it, will say, well, the number of hurricanes are increasing and we need to do something now. Well, if you look from the year 2000 on for a couple of years and ignore this stuff, then yeah, it looks like it's increasing dramatically. But as you average things over a long period of time, now this isn't really a long period of time, this is just 12 years. Be interesting to see, because things do increase and decrease in cycles, but there doesn't seem to be a correlation here. It kind of bounces up and down. I mean, if I ignore some of my data, I could say, hey, it's going down. But you don't ignore data. On this, it looks like there, from my point of view, there is no correlation. And I would describe this as the number of hurricanes in the Atlantic tend to jump around from year to year, sometimes being a high number, sometimes being a low number. It depends a lot on the weather patterns for that year. Okay, let's look at cereal bars. Cereal bars, we've got the number of grams of sugar and the calories. We actually saw this one on yesterday's video, so I'm not going to say a whole lot about it. You can look back at yesterday's video. But it does have a positive relationship. cereal bars with more sugar tend to have more calories. There appears to be a little bit of clustering right here, maybe some outliers. This is kind of an outlier, maybe that one is too. But it's got a kind of a weak association somewhere through here, but it is positive. Okay, beach visitors. This is the average daily temperature in degrees Fahrenheit and the number of visitors to a particular beach. Now, looking at this, it does look like it's got a positive relationship. So let's go ahead and say it's a positive association, a positive correlation. And it looks like higher temperatures see increased beach attendance. So as the temperature goes up, there tends to be more people going to the beach. Now, as far as outliers, this is kind of an outlier. I'm assuming that on this day, it was pretty good temperatures for going to the beach, but it was probably raining. It may have been kind of a stormy day, so people avoided going to the beach, even though the weather was nice. So there could be another variable that affects these things. Okay, ice cream cells. We've got the temperature versus cells. Okay, this one shows a positive relationship. And I would say on this one, on warmer days, more ice cream gets sold. And that one makes sense. An important thing to recognize about correlation, just because there's a correlation between two variables does not necessarily mean one of them causes the other. It could be that there is a third variable we're unaware of that caused both of them. Now on this one, there's probably a little bit of cause-effect here. As more ice cream gets sold, the temperature tends to get higher. Actually, it'd probably be the other way around. On warmer days, people are going to be more in the mood for ice cream than they would be on cooler days. As far as cause-effect here, I think that the temperature does have an effect on the number of beach visitors. The amount of sugar does have an effect on calories because sugar is a carbohydrate, and carbohydrates do contribute to calories. Right here, the year versus Atlantic hurricanes, there doesn't seem to be a cause-effect relationship here. By the way, when you're comparing things to time, you are usually trying to figure out if things are changing. And here, yeah, they're changing, but there's really no pattern to the change. Right here, does family size affect the number of loads of laundry? I think that is a cause-effect relationship. And then right here, does the size of a TV affect its price? I think it does, because a larger TV requires more material to create, more technology to create all those pixels. Does a person's age affect the number of pets they own? I don't think so. I don't think it goes the other way either. Otherwise, people would be able to get more pets to change their age, or maybe as they got older, they just automatically get more pets. It's based on other factors, mostly personal preference. If a person wants more pets and they are of the age to make those decisions for themselves and they live in a place where they can have pets, they tend to have pets. Okay, on your assignment, number 1, tell whether the data shows positive, negative, or no relationship. Explain. This is just positive, negative, or none. And then explanation. As x increases, y decreases. As x increases, y tends to vary randomly. As x increases, y increases. That sort of explanation. Number 2, the scatter plot shows the number of sport utility vehicles sold in the city from 2009 to 2014. And then there's a couple of questions. Part A just has you reading the graph. Part B has you reading the graph. And Part C describing the information, what relationship you see in the graph. Number 3, review of solving. You can either use graphing or the transitive property. Number 4 is a review of finding the volume of a U.S. quarter. You should know that that is in the shape of a cylinder. It's a very short, wide cylinder, but it's a cylinder nonetheless. Number 5, you get a graph. Number 6, you get to write the equation of the line graphed. Number 7, create a possible scatter plot diagram for each real-life situation. Do not collect any data, just draw a diagram of what you would expect for each situation. Identify the type of relationship. Now here your answers will vary. Late fees versus books checked out. We've seen one like this, but in certain circumstances with certain populations, it could have some sort of relationship. And body part comparison, length of it, right index finger compared to length of arm. And number 8 here, describe what relationship you would expect between the two data sets. And it's got just a situation. On this, there's no picture. It's just using your brain and your experience to decide whether this would have positive relationship, negative relationship, or you don't expect there to be a relationship. Like right here on part C, the number of toppings on a pizza and the cost of the pizza. In your experience, if a pizza has more toppings, does it tend to cost more, tend to cost less, or tend to not make a difference? So that's kind of what you're looking at there. Please complete that assignment, and thanks for watching.